Hi, this is Dr. Nick with the ECG Academy, and we're going to be talking about the ECG leads in this first chapter of Section 5. What is a lead, and what does it mean when you change leads? We're going to talk about the basics, because when you look at a 12-lead ECG, you see these lead 1 and lead 2, and on monitors there may be a switch that you can change which lead the monitor is looking at, and what lead you pick is going to have an effect on the way the ECG looks. In the intermediate section of the ECG Academy, we're going to be talking about a more advanced concept of the ECG axis. And that involves some calculations, and the axis deviation is a term used to describe an abnormal ECG axis that we'll get into as far as the physiologic disturbances that can result in axis deviation. But again, that's an intermediate concept, and we're not going to be talking about axis, but I do want to introduce you to the concept of the lead. Now, what is the lead? Well, okay, let's just talk about the recording systems that we had discussed in the past. Remember, ECG basically amounts to a voltmeter, and there are electrodes that are monitoring voltage in a bipolar recording system, that is. And when you have an electrical signal that's traveling in space, what happens is if it reaches one pole first, the voltmeter will measure a signal that amounts to the fact that the one pole is more positive than the other. And then as the signals pass, as a signal passes to the other pole, you may see a change in the polarity. And then as the signal continues to move, the recording will go back to the baseline state. But remember, if the electrical signal is traveling in the perpendicular direction, so for example, if it starts up here, let's erase this, and if it reaches both poles at the same time, then there's no difference between the two poles, and the electrical signal that's drawn may be very small or even non-existent as this wave of depolarization travels perpendicular to the plane of the electrodes. Okay, we remember this concept from one of the early chapters. All right, so what are we talking about in a person when we're looking at the electrocardiogram coming off of an ECG system? Well, remember we have different color codes. The black is the left arm, white is the right arm, green is the right leg, and red is the left leg. Well, in the early days of electrocardiography, they used a bipolar recording system to look at the electrical signal that's traveling between the right arm and the left arm. Now, just as a review, I want to remind you of what direction the electrical signals in the heart travel. Remember that the atrial signal starts in the high right atrium, and it travels down and to the left. And likewise, the signal that goes through the ventricle travels down the septum and towards the apex, down and to the left. The normal electrical signal travels down and to the left. Now, in physical terms, this kind of directional movement of an electrical signal is called a vector. A vector is any force that has an amplitude or size and a direction. So the fact that electrical signals during cardiac depolarization travel in a certain direction is going to become important. Now, the first lead we're going to talk about is lead 1, which happens to be between the right arm and the left arm. So imagine that voltmeter now is connected to the right arm and the left arm. The way the polarity is set up in the machine is that signals that are traveling in this direction from the right arm to the left arm will be inscribed on the paper as a positive deflection. Okay, so any signal that's traveling from right to left is going to look upright on the ECG. Now, since the P wave and the QRS complex are both traveling down and to the left, they'll both appear positive in this very simple bipolar recording. And so your ECG will look like this when you record it from the right arm to the left arm. Now, by convention, right arm to left arm is known as lead 1. Okay, that's the idea. Lead 1 is from right arm to left arm. And in a normal person, it will look kind of like this, with a P wave and a QRS complex that are both upright, because the P wave is traveling in this direction towards right to left, and the QRS complex is traveling right to left, isn't it? So that's lead 1. Well, what about the rest of the leads? Well, it turns out in most ECG systems, the right leg is at ground. So it's kind of like helps the machine determine where 0 volts is, and in some ways it kind of avoids excessive noise in the recording. And so it's the left leg that becomes important in recording ECGs. Now, lead 2 is recorded from the right arm to the left leg. Okay, so the right arm to left leg is lead 2. And then the left arm to the left leg, and that is lead 3. Now, one of the pioneers in electrocardiography was a guy named Einthoven, and he described Einthoven's triangle, which had a lot to do with the early leads and the way he devised how lead systems are going to be created. And what he described as lead 1 being from the right arm to the left arm, lead 2 being from the right arm to the left leg, and lead 3 being in this direction from the left arm to the left leg. Now, this was Einthoven's triangle, and we're going to talk a lot more about this in the next lesson, but I want you guys to understand the concept behind each of these leads. There are 3 other limb leads that we can talk about, and these are known as augmented limb leads. It has to do with a unipolar versus bipolar recording, because what the machine will do is, for example, take the left arm and compare it to the right arm and the left leg. It'll kind of hook the right arm and the left leg together, and then measure the voltage in the left arm compared with the sum of the voltage here. And it gives you a direction that is kind of headed towards the left arm. We refer to that as an augmented lead. It's known as AVL. Likewise, there's an AVR, and there's actually an AVF, which again are kind of sort of semi-unipolar leads, AVF looking at the left leg compared with the sum of the 2 arms. This will make a lot more sense when I talk about the circle around the patient that relates all the frontal leads to each other. And so go ahead and watch Chapter 2 of this section, and I think it'll make a lot more sense. Well, this is Dr. Nick for the ECG Academy. See you then.